All right, in this video we're going to talk about parametric equations and their graphs. And a set of parametric equations are when you have two different equations dependent upon the same parameter. Now, a parameter is nothing more than what the input variable is for both equations that would match. So I have an x equation that is dependent upon t values, just like y is dependent upon t values. And the difference is parametric equations, they're not held to the typical standards of our Cartesian equations in terms of being able to graph them. Our calculators can actually make pretty cool graphs of parametric equations because it can make curves that fail the vertical line test, they can zigzag, they can do all kinds of different things. And in this video we're going to focus on just graphing them. Now, if I'm trying to create a graph, and we're going to start at the very top one here, and I'm given a set of parametric equations, basically what I would do is I would create a table and pick t values. Now, I've already picked some t values here, and I'm going to plug in for both x and y and write down. I'm going to create a set of data points so that way I can graph. Now, I want to show you how to do this on a TI calculator. And so what you would do to create your table here is, believe it or not, your calculator has a parametric mode. So if I press mode, I go look, it'll be PAR for parametric, and I want to make sure that that is selected. Now your screen might look a little different, but it should have parametric mode. Once you do that, when you go press y equals, it's going to look different. You're going to see x1, y1, x2, y2. And this is where you type in your parametric equations. And I get the t's to show up by pressing the same button I would if I was graphing a normal equation. You know, a lot of people call it the x button, but it's really the input button, and it'll automatically put t's there. And then you can go to your table. And so that way I don't have to do so much evaluating. If I can go to my table, and it'll give me a column for t values, and it'll give me a column of x's and y's, so that way I can just copy them in. So when I go to -2, I have an x value of -7, a y value of -3. -1, so -4, -1, zeros, -1, 1, 2, or 1 is 2 by 3, and then 5 by 5. So I have those set of points. Now, your calculator can also graph parametric equations. So if I were to press the graph button now that I got my table, and I look, and it turns out to make a straight line, where I could actually trace. Now you'd use your arrow keys, but I could trace, and I could see at any time t, I look at the top, t right now is -0.8. It tells me what x is and what y is. So I'm going to get the calculator off the screen. We know it's making a line, but I'm going to go through and I'm going to try to plot those points. Now, when you plot the points, so the first coordinate I have has an x value of -7, a y value of -3. So I put that dot there. What I want you to do is I want you to indicate the t value. So the t value there is -2. Now, you don't always have space to do that, but it's good practice to do this because we want to indicate the direction on these parametric graphs. All right, so when t is -1, we have the coordinate -4, -1. So that's t equals -1. And then at 0, we're at -1, 1. So that's t equals 0. And when t equals 1, we're at 2 by 3. And then we're at 5 by 5 when t equals 2. And I would connect those, and I would indicate the direction. Now the t values tell me the order, but you can indicate the direction with little arrows here. This next problem, we're going to graph using Desmos. So, well, technically we're going to fill in a table and we're going to graph it by hand, but we're going to let Desmos help us make a table and kind of give us an idea of what's happening here. So I'm looking, we have a parameter defined, our parameter's t, and x is defined as 4 sine of t plus 2, and y is defined as 2 cosine of t minus 1. And so if we bring Desmos up, Desmos can graph parametric equations, but I have to type them in actually very carefully. to make it work. And so what you would have to do is you would have to type in your parametric equations as a coordinate, which I have up here at the very top, where the x coordinate per se is 4 sine of t plus 2, and 2 cosine of t minus 1 is the y coordinate. And to make the table, because Desmos is kind of particular about how you type it in, because both our x component and y component depend on t, what you do is you would take your equation here after you typed it in. All right, and then I would need to define all of my t values that I'd want to use, and you create an element list. So I would type it in exactly the way I do here in the second one. And what I would do to create my table is I would select the function, click the gear, I'm going to copy it. And so it copied it right here below it, and then I'm going to click the table. And so for every t that I had defined in my element list, it's going to give me the corresponding x and the corresponding y's, and it plots them for me. Now, they are in order as you go down in the table. That the highest point in the table is when t is 0, and as you work your way down, your t values are going to the right. And so that is what, it can plot it for me. I can get my values to fill in my table as well that way. Now let's look at how we would actually graph this with Desmos. So I'm going to delete the table and the list. And when you type in parametric equations in the Desmos, it's going to want you to put the interval for t, or whatever your input variable is. And I'm going to say, all right, well, we have trig functions. Let's go from 0. We would go from 0 to 2 pi. Well, actually, let's go from 0 to 2 pi and see, and then I'll turn on the graph. And we look, and it makes an ellipse, which is kind of neat, but I don't necessarily know, without the data points being on there, where I started and where I ended and which direction am I going. So a little trick that we can do is we can take this upper limit of 2 pi, and I'm going to make that a constant c. And it's going to ask me, do I want to add a slider? Well, yes, I do. So I'm going to click that, and it's going to give me the c here. And I'm going to change the limits to go from 0 to 2 pi. And I'm not worried about the step. All right? And so it makes my slider. And so I can physically slide starting at 0, and I can work my way to 2 pi, and I can see that as what it's doing as it goes, my t's go all the way to 2 pi. I'm working my way around. So I make that ellipse by actually starting at that top point at 2, 1, and I rotate to the right. So then I can indicate my direction on my graph. So I'm going to go back to our problem. And I have all the tables filled in. I plotted my points, and I'm particular. I like to indicate my t's on there. And then we're going to sketch. Now, with my t's, I don't really need to look and indicate direction because my t's are going to tell me the direction. But I'm going to sketch here, and as I work my way around, it's supposed to be as rounded as possible. I'm going to put arrows indicating the direction that it's heading. And I'll just put it in between all my data points.